How'd that do?
I mean, you can see it.
Yeah, you can see it. I mean, if they had the lights off, you could see it better.
Just goes away like 5 seconds.
And hey, these bell ringers got returned, but I wasn't here for this 8:28, and then I was just now about to answer.
Y'all wasted way too much time arguing about who lost 2 sunflower seeds and not working and
8:28 was yesterday, bro.
Wasn't here.
Alright, let's get the smartboard page up. That'd be a good place to
I
start.
wasn't.
She works.
Page thing.
Another.
She takes attendance.
First thing we're going to do is talk about some different words that we have. So if I label a colon ADDIT addition, I need us to come up with some words that we would see in word problems that could mean addition.
Some.
Some, that's a good one. Keep going.
Add.
Add. There you go. That's right. So I need it right. What else?
Hospital.
Plus.
Plus. Okay, keep going.
Profit.
That could mean a positive, but not necessarily addition. I like to think of them. Anything else? There's several more. Addition's got the most of them. More than's a big one. That's in word problems a lot. If I say you had 5 more than 7, you would add. What else? Some add plus more. Some start with an I.
Would gradual be one?
It increased.
Gradual?
Gradual could, not real common one though, but it would be gradually increasing. Those can kind of go together on that.
You said 2 of them have an I?
Oh, I don't know. I only knew that one right there. There might be another one. Anybody think they got another one? Yeah? We could combine them by adding. Say that again.
Can I look up some?
Yeah.
What you say, addition synonyms?
Yeah, words that mean addition would be good, yeah.
Combine.
We've got all of them I have in the book of your own. We got some, more than, plus, added, increase. All together is a good one. I like that. All together, above. I never used that one before.
Well,
Above.
there's a bunch on here that I'm going to
Okay, well, we're not going to list them all. We'd run out of paper. Run out of smartboarding. Hate it when that happens. It's expensive.
I think you need to ask Caleb if he can go get you some more.
Caleb,
Yeah. Huh? Can you?
if we
She
run out
needs
of
some more
smartboarding, we'll ask you
smartboard
to
ink
go get it.
from the office. They hand out smartboard ink for those pens right there.
I'll go get it.
Can you go get it?
Oh yeah, I'll go get it.
Go get it.
Michael's never coming back.
No, I get what you're doing here. I just think it'd be funny for me to go in there and ask them.
Do you get it, Bo?
Alright, what about some subtraction words?
There's no ink for it, bro.
I know, fam.
Something means subtract.
What you think about?
Subtract.
Yep. Less than.
Is it different? Wasn't different?
I got less than, then Kaylee said minus. Mason said difference. What else we got? Decreased. The only other one in my book list that y'all hadn't yet is just the word, like subtract. But I think that one's pretty self-explanatory. Okay? Any other ones that y'all can think of? Yeah, a loss would indicate that. Oh man. A loss would indicate we're going to subtract. I like that. Grace, you had something on your mind. Did you lose it?
No shit.
Less than.
Take it. Yeah, I like take away.
Yeah.
We got that one already, huh? Take away. Okay, good. Good. Y'all came up with some other ones my book didn't have. That's good. All right. So we got some addition. We got some subtraction. Next page, we're going to do some multiply and divide ones. So you're thinking on those. Multiplication. Fewer would be a good one to add on subtraction. Yes. 5 fewer than 3 would mean we're subtracting on that. Good. Okay. Multiplication. What we got on multiplication? Yeah, just use the word multiply. That's the big one there. Product, chase. Keep going. Times. I like it. There's a funny little short word that means, it's not a funny word, but it's funny that it means multiply to me. A funny little short word just has 2 letters in math that means multiply. It's a normal word you use in everyday conversation, but in math it means multiply. Of. Very good. Of. It's always funny to me to think of is a multiply word, but it is. See that a lot with percentages, and we're going to do some percentages today. You could get into some specifics, like if somebody said twice, that would mean you're multiplying by 2, right? So I'm not going to list all the specific ones. We got, let's see, times, we got multiply of twice as much as product. So we got, anything else y'all can think of?
Mm-mm.
Okay, you said no?
Product.
Yeah, we got product.
Oh.
Area.
Area, no, oh, because the length sounds weird, I guess, is what they're thinking of.
Each.
Yeah, that's not bad. I never thought of writing that one. Good. All right, let's make a division list. My division list was my shortest one, and the book's shortest one also. What do you got for division?
Divide.
Divide. Attaboy. When you get into fractions, it could. You could. I'm not going to write it because I don't want to confuse myself and multiply. Okay. Michael's having a thought for one that's going to be hard to get. We know, Hayden, if we know if we have a fraction, so if we have something over something, like you said, 10 over 2, that would mean you're dividing with 5. And there's a word, a math word for that starts with an R. Anybody know the math word for how you can write something in a fraction form that starts with an R?
Isn't it right?
Rise over run.
Ratio, very good. Ratio would imply division because it's got something over something. Very good. Yeah, that would be like your quarter or your half, and so we're splitting it, split into so many parts. What else? Quotient's the big one.
I don't even know how to pull that.
We got quotient, we got divided by, we got ratio. That's all my book has. Got anything else? Say that again. Yeah, that one would be true, but they don't have to always be even either. So,
Fraction.
yeah, that would be our ratio one. So that's good. That's good stuff. All right, anything? All right, so I'm going to give you now a verbal sentence. Good list there. We're going to need those. I'm going to give you a verbal sentence. That means I'm going to write it out with words, and you're going to write it and make the mathematical equation out of it. Okay, so my sentence says the quotient of a number and 6 is, added to twice the number is 7. Okay, so there's our verbal sentence, and we're told to write that in an algebraic equation. Okay, so we're going to write our equation going left to right, just like we read the sentence. So first thing we see is quotient, which means we are dividing. So I got the quotient of a number. When it says of a number, that's your freedom to choose whatever variable you want. Okay? Hunter could use an H, Baylor could use a B, you can use whatever letter you want. I'm picking X. So that's what I'm doing. The quotient of a number and 6. How's that? Does that show the quotient of a number and 6? Mm-hmm. Is that the only way to write that? No, you could use your old school division sign. You could use the slash. This is probably the most common way there, so I'm going to go ahead with that. Then after the comma, it says added to twice the number. So you know added, you've got your plus sign. What's twice the number? 2x. Got to use the same variable because they're saying that same number. Is. What does is mean in math? Equals. That's why we know it's an equation. There's your equal sign. Is 7. So that'd be our answer. Now we know how to solve that. We could solve that. We're not going to. We're stopping there because all I asked for was the equation. When we're in chicken dinner, you got the equation. Alright, we talked, I believe it was on Friday, on deciding whether or not things were expressions or equations, and it was based on the equal sign or not, basically. This was an equation because we got an equal sign. It hits that again in this unit. This lesson, I'm supposed to give you some examples of that, but I don't really think we need to unless you do. Y'all remember how to tell the difference between an equation and an expression? Everybody feel confident on that? Equal signs an equation, no equal signs an expression? Got it. All right, good. Now, getting into some of these word problems, you're real good at solving equations. The dilemma that we're going to see here is that we've got to write the equation out of the word problem before we can solve it. So I'm going to read and we'll make some notes and we'll try to get good at writing these equations. This first one's a good old rectangle question, so I'm going to go ahead since I know it's a rectangle and draw one. I like that one. That's the best rectangle I've ever drawn. All right. It says the length of a rectangle is 5 centimeters more than the width. The perimeter is 5 times the width. What's the dimensions of the rectangle? All right, so let's read it again and fill in the stuff on our picture here. The length of the rectangle is 5 centimeters more than the width. So this length has got to be 5 more than something. How big's my width? Right, so pick a variable. I use W for width. You can use, that would be confusing. You could use any letter you want. I use W for width. So we know that on a rectangle, opposite sides are congruent. So we know this one would also be a W, and this one would also be a 5 plus W. Okay, everybody okay on that? That wasn't rocket science. We can do that. All right, then it says the perimeter is 5 times the width. Perimeter is what you get when you add all these up. Okay, now there's 2 W's, right? So I have 2W plus, then there's 2 of these. So 2 times those, and it said that is equal to 5 times the width.
Where'd you get the other 2?
This one, because I had 2 of those. 5W, 5 plus W. Yeah. Yeah. All right, so now I'm ready to take care of that step that Baylor just saw, and I can distribute that too, can I?
Yep.
And y'all probably would have skipped that, which is probably why you didn't see that. So I would have 2W
Plus 10.
plus 10.
Plus 2W.
Plus 2W. It's equal to 5W. Okay? Now you've done the hard part. You've written the equation. You just got to solve it. You got some like terms to combine.
I mean,
Right?
so just subtract 4.
Good job, Sir Baylor. Oops, I started writing S. I don't know why I would want an S. Because I'm silly. Alright, so we know the width. The width of a rectangle is 10 centimeters. So we've got the width. So what's the length?
It should be 10.
No.
Or, I mean 15.
Good, because it's 5 more, so our length would be 15 centimeters. Nicely done. That 5 has a big hat on it.
Sure.
They alright? Good. Good over there, Caleb?
No, for real, didn't take it. I'm dead serious.
Okay, this next one that we got, on some baseball stats. So everybody got the
Alright.
stuff you need on that one? Alright, I'll read it to you, and then we'll go back and make some notes and try to write the equation. It says for the 2008 baseball season, the Major League leaders in RBIs were Ryan Howard of the Phillies and Josh Hamilton of the Rangers. These 2 players had a total of 276 RBIs. Ryan Howard had 16 more than Josh Hamilton. How many did each player have? Okay, first off, I grumbled a little bit at this question because I wanted to use the variables of their names, and they were Howard and Hamilton. So I couldn't do that. So I went to their first names. So I'm going to let Ryan Howard be R and Josh Hamilton be J. So I know that Ryan Hamilton, or I'm already messing up, Ryan Howard plus Josh Hamilton, the problem told me that their RBIs together totaled 276. Okay, so I'm starting on that. But then it gave me some more information, because like that, I can't solve that. I can't have 2 separate variables and be able to solve it. I got to get them in terms of one variable. And it gave me that information because it said Ryan Howard had 16 more than Josh Hamilton. So if I take whatever Josh Hamilton had and I add 16 to it, that would be Ryan's, wouldn't it? So I've got Ryan's here plus Josh's equals 276. Okay, so what would step be to do to start solving this?
You have J plus J.
Subtract
Or,
16.
is that what you meant to do?
Hold on, Custom. Say that again, Mason.
J plus 16 plus J. Is that what you meant?
Yes, because this J plus 16 is the same as Ryan. Because
Oh, okay. I understand
Right.
it now.
okay, Keston did something that I would not have done first, but it works, so I'm going to do it. Okay, she subtracted the 16 first. It's not wrong. It's just isn't what I would have chose, so I like to get out of my comfort zone every now and then. So now I've got over here a J and a J would equal 260. Now Keston would do, I hope, what I would have done first. What would Keston have to do here?
Divide.
Good. And you already know that. That's kind of a common sense step. You know that a J and J is 2J. So to finish that off, solve, divide by 2. And Josh Hamilton had 130 RBIs.
So R is 146, right?
So good to figure out how many Ryan Howard had. You could get it a couple of different ways. You could subtract Josh's from the total, or you could, the easier thing in my opinion, you could just add 16 to the Josh's, right? 130 and 16 means Ryan Howard had 146.
There you go. I for real don't have it. I'm for real just tired. Do you for real not have a cat?
I don't care where it is. Fuck that hat.
I don't want that. I hear you for real.
Well, that doesn't mean
I know,
that
I
it's
do want
necessarily better. That just means he's
I don't
better at
have it.
Yelmer. So you can go in
What does the J
Search
stand
my
for?
web.
you're still
No,
working.
nigga,
Say it
if
again.
one of you niggas has it, I will find it.
How much you want to bet that I don't have?
Josh Hamilton.
Nigga, obviously you don't have it because you want to bet. I gave it to him. I don't have it.
Okay, yesterday we talked about percentages. We're fixing to hit that again.
I don't care.
We good? Percentage that we looked at yesterday, you already wrote this, you don't have to write it again. We talked about the part over the whole was equal to the percentage in decimal form, right? Now another way of saying that, a way I'm going to give you a shortcut on it now. A lot of these word problems, y'all listen, a lot of these word problems we talked about the word of. When it's percentages, they're going to be use that of, that multiply word. But percentages, a shortcut is over of is equal to the percentage as a decimal. Now that sounds screwy because you're like, that's English, is and of stuff. But I don't know why that's pretty common in these percentage problems. And that is over of shortcut has made my life a lot more simple. I never had heard that until I was a teacher at a different school I was working with was doing that. The kids were coming to my class and being like, is over of. And I was like, what the crud's is over of? It works. It works every time. So we're going to use that in this problem. I'll read it to you and we'll talk about how to fill in the blanks here. All right, it says 187.5 is, I emphasize it on purpose, 187.5 is 125% of some number. What's the number? Okay, so you read problems like that a lot that have that is and the of in there. So all I got to do is fill in where they go. 187.5 is. So that goes on the top. That's the is.
Can you say that so I
Good
can
choice.
so I can write that down?
Uh-huh.
Like the whole thing.
187.5 is 125% of some number. What is the number? Okay, so it said of some number, so I don't know the of number. There's your variable. And it said, what did it say 187.5 was? 125%, but I got to make that a decimal. So it'll be 1.25. Good job. Now, we got here first period, and they were saying, well, it's being divided, so you're going to multiply. Not necessarily. The variable's on bottom. What I like to do when the, excuse me, I had a hiccup. When the variable's on bottom, that 1.25 is the same as 1.25 over 1, isn't it? You got a proportion, right? So that gives me 1.25x is equal to 187.5. So what do I got to do to solve that? So I'm dividing both sides by 1.25, and what was our number? 150. Thank you, sir. Caleb?
Nice. Nicely done. Nicely done.
So what you got? Checker over there, Dustin?
Checker.
My checker failed me again this morning, so make sure you're on it. That he just nods and smiles whether or not he does it or not. It's confidence.
That's what I was about to say. It's all
exudes.
confidence.
That's right. It's like even if you're an umpire or referee, you blow the call, you gotta do it confident.
Yeah,
You're
that's
like,
that's why they always scream.
yeah.
Like it's top of their lungs.
I don't know. I don't play any sports, so.
Oh,
You
me
know
neither.
what?
Oh, it's okay. Everybody doesn't have to.
He said,
I play here.
I play that.
Ballerina.
Rio? Oh, really?
Dude, that honestly would be so funny if you were. I would laugh so hard.
Not the only time I wear
Well, we're gonna move on to math now. You remember that's on video, just so you know.
Right here.
Hayden just
Hey,
woke
wait,
up
zoom
in
in
top
on
of
him.
that. Like, you mean to repeat what you said? Okay, got an investment problem that we're going to do here real quick. Common investment formula. This is the most common formula. Interest is equal to the principal times the rate times the time.
Whoa.
That's we did that in Algebra 1 and Algebra 2. That's the most common
Blew it, man.
formula. There are some more complicated ones depending on how your interest is figured. We did in Algebra 2 that we used the PE, the number E. Remember that number E? We used PERT and all that kind of stuff, but that's the most common. All right, let me read you the question so we can get unconfuzzed, and we'll make some notes and figure this out. This isn't that bad. It says a man has $34,000 to invest. So I'm going to put over here what I know. We got $34,000 to invest. He's going to invest some of the money at 5%, so it's going to pay back 5% interest. Then he's going to invest the balance that's left over at 4%. So he's not putting it all on the same stock or bond or whatever he's doing. Okay? His total annual interest income is $1,545. So he's going to earn out of his investments $1,545. The question says, find the amount invested at each rate. All right. This is not that bad. We're going to have an amount he invested $5,000 plus the amount he invested. I said that wrong. Rewind. We're going to have the amount he invested 5%. Plus the amount he invests at 4%, and that will give us the total he earns, right?
So we got to get 34,000 and 100%.
That's a good way of thinking about that. Yeah, yeah, kind of. That is going to come into play. Hold on to your thought there, Baylor. That's good thinking. All right. So how much did he invest at 5%? We don't know. Variable. Okay. 5% would be 0.05. If he'd invested, for pretend, $100. I would say $100 times 0.05, right? But I don't know the amount, so it's 0.05 times the X that Michael picked for us. Plus 4%. How much did he invest at 4%? This is what Baylor was talking to.
$1,360.
How do I know how much? Pretend he invested $20,000 here. If he had $34,000, how much could he invest here? Because he subtracted, right? Everybody hear what Chase was talking about?
No.
So if we had $34,000 total, and I'm just pretending that he put $20,000 here, what's left? Okay, so that's what we've got now, but we didn't know this, so we're going to write that as just like Chase subtracted at a kid. Okay. Now, what does that have to equal? What he's making, his interest. So equals $1,545. Alright. So, what do we have to do to start cleaning that thing up? Distribute. Good job. So I got 0.05x plus, I don't know, I need help. What's 0.04 times 34,000?
Calculator or something.
Oh, 0.04.
Uh-huh.
Wait.
1360.
1360.
Okay. And then minus 0.04x
0.04.
equals 1545. Oh, y'all, I think I wrote wrong what y'all told
Yeah,
me.
it's like 1,300.
Yeah, I was thinking 13,060.
I had to double check.
Alright. I got some like terms on the left side that are pretty simple to combine. 0.05x and negative 0.04x would be 0.01x. Now, even though they're different numbers than normal, we got a big number and a little number, it's still a two-step middle school equation. What would I do to start solving?
Figure out what
Good
x
job.
is. It's like 300.
So it gets me 0.01x is equal to
185.
185. Okay, so my last step to solve for x. Yes, sir. Yes, ma'am. And what we got?
18,500.
And my x in this equation was how much I was investing at 5%. So I'm investing $18,500 at whatever it was that was earning me the 5%. Okay, but we were also putting the rest of our money at the 4%. So what's the rest of it? 34,000 minus 18,500. What does that leave us? 15,500 got invested at 4%.
Angry. He's asleep.
Okay, these last two problems that we're going to look at before I give you one to do on your own. This is what is called mixture problems. And if I told you what my greatest difficulty in math is, it's mixture problems. Not that it's difficult, but they take me a while. I don't know why. My brain, I got to think about them and digest them pretty good. And it really aggravated me. I don't know if it was the first or the second week of school, they were doing mixture problems in the college algebra class. So when they ran into a problem on any of their homework, they immediately run in here for me to bail them out. And they get mad at me because they brought this mixture problem in here, and I looked at it and I said, write it down for me so I can work on it and come back later. They wanted the answer right then, and my brain doesn't work that way on mixture problems. So the reason I'm telling you that is because just because it's more difficult to me doesn't mean I don't have to do them. It means I got to think a little bit, which you sometimes are going to have to think a little bit. One thing that helps me on these mixture problems is to make a table. Every time I have a mixture problem, I'm going to make a table. And the good news is the table is pretty much the same for any mixture problem. So if you can set one up, you can set them all up. Okay, I know y'all are going, what the heck is she talking about a mixture problem? I'm glad you asked. Here we go. How many, a chemist is mixing 8 liters of a 40% acid solution with some 70% solution to get a 50% solution. How much of the 70% solution should be used? So now you know where my confusion lies. All right, my table, I'm going to have a number of liters. So I'll just put an L there for a number of liters. Stuff that I know. I know the percentage as a decimal that he's going to use of that. Percentage as a decimal. We'll put it in there as a decimal. And then I'm going to be able to find out the liters of pure acid. So I'm just going to put pure because that's what this problem's about. Okay, let's read it again and start filling in some of that stuff now. It says a chemist must mix 8 liters, 8, of a 40% acid solution, 40%, 0.4. Okay, 8 liters of a 40% solution of, what am I going to do? Multiply, so that means that's going to be 3.2 liters of pure acid. Okay, we got more. He's mixing this with some 70% solution. So I'm on a new row here. 70% is 0.7. How many liters did it say he had? It just said some. Variable. Would be 0.7x. Okay, so I don't really understand the acids and all that, but I can fill in a table. We're going pretty good here. All right, we're mixing these liters together. So I've got an 8 liter and an x liter, so that'd be 8 plus x. Now here's where you got to be careful. Lots of times because I added that, people will think they just get to go and add 40% and 70%. No. First off, that's more than 100%, right? So that's no bueno. The problem said he's wanting his solution to be 50, was it 50? Let me read it again. Chemist must mix 8 liters with 40% with 70% to get a 50. He's wanting a 50% solution. So this is going to be my 50%. Okay, but now just like we did on the previous rows, we multiplied. We're going to multiply here. We just got to make sure we multiply the 50% times both of them. So 8 times 0.5, 0.4, and x times 0.5, 0.5x. Oh, 4, my bad, thank you. That would mess me up. 8 times 0.5 is 4. Well, Chase, you should have told me. It's 40, and you take one place off for the 1 decimal. That makes sense. Good job. Okay, so that's what we're mixing up here. So that means whatever I have of this plus whatever I have of this has got to equal that. So I'm going to add and set it equal. And that will work, get you through just about every mixture problem there is. There'll be different types. This one's about acid. The next one we're going to do is about gasoline. There's lots of them about mixing candies. Like you get 4 pounds of dry nuts and 4 pounds of M&Ms and mix them with, you know, all kinds of stuff like that. All right, here we go. 3.2 plus 0.7x is equal to 4 plus 0.5x. So once I get to that stage, I'm pretty relieved because here I was struggling with some chemistry problem that I had no clue about, but I'm down to an algebraic equation that's not very difficult to solve.
Correct.
Is that
Yes. All right, so what do you want to do first to solve this thing? Okay, Haley's subtracting the 3.2, so I'm going to go with her on that. Subtract it from itself and from its like term on the other side. That gives us 0.7x is equal to 0.8 plus 0.5x. All right, we don't have much of a choice now. What we got to do?
subtract 0.5?
Good job, Miss Ricketts. Subtract the 0.5x. So I've got 0.2x is equal to 0.8. Divide. And what do we got? Did Chase say 4? So what is it? 4, and this would be, what were my units? I forgot. Liters? Yeah, L up there on top. So there were 4 liters of that solution added to our bowl, or pot, or beaker, whatever we're mixing acid in. I don't recommend it. It's bad to say we're mixing acid.
Why did they come here?
Is that all we have to do?
That's some snooze. Like, look, the camera around.
Okay, want to do one more mixture problem.
Okay.
Add a little bit of a wrinkle to it. Everybody good?
Sure.
Sure. All right, this one we're talking about gasoline, and there's some stuff in this. I don't even know what it is. It's okay. Let me read you the problem, and then we'll get through it. It says the octane rating of gasoline is a measure of its anti-knock qualities. For a standard fuel, the octane rating is the percentage of isooctane. How many liters of pure, and that's important, pure isooctane should be mixed with 200 liters of 94% isooctane, referred to as 94 octane, to get a mixture that is 98% isooctane. And at that point, my head starts spinning, and I'm like,
Oh, the octane.
yeah. I don't even know what isooctane, I-S-O-C-T-A-N, I don't know. All right, so make a table. Liters. If it was in grams, we would put a G, you know, being flexible on that. Percentage as a decimal. And then this one, we had pure acid on the last one, so now I'm going to have what we're talking about, the pure isooctane. Alright, so let's fill some stuff in. For a standard fuel, oh, we already got that. How many liters, so I'm starting right off the bat, I don't know something. How many liters, right, of pure isooctane, pure. Okay, if something is pure, that means all of it is that. So what's the percentage of something that's pure? 100 as a decimal? 1, just 1, right? Okay, so that would multiply out there. how many liters of pure isooctane must be mixed with 200 liters of 94%, so 0.94. Help me out, what's 200 times 0.94? 188. You missed a decimal somewhere. Oh, yeah, I did. Okay, now just like before, I told you the good thing about these, or that the tables all work out the same. We're mixing these together, so we're going to have an x plus of 200. This one, though, you don't just add that's more than 100. You look at what the question asks for. So I'm reading the question again. It says to get a mixture that's 98%. So I'm going to put a 0.98 there. They told me that. So now I got to distribute the 0.98 to both of those. 0.98x plus, what's 200 times 98? 196, is that right? Should be. Y'all check me out. Make a checker. 200 times 0.98. Thank you. 196. I should be common sense to y'all, but anyway. Alright, so just like before, I told you this is good stuff. Add them, equal. So x plus 188 is equal to 0.98x plus 196. Alright, where you want to start? Start with any of the four. Subtract 188, Kaylee said, so I'm going there. So that gets me x equals 0.98x plus 6. Now we don't have a choice. What would be a good move? Yeah, subtract the 0.98, good. So that'd be 0.02x is equal to 6. Divide by 0.02. And how much of this, how many liters of pure isooctane do we have? 300. Shazam.
And that's it.
Yep, that's it. So again, you know, we just don't get bogged down that I don't have any idea what isooctane is, you know, and the table will work for you every single time. Okay? I've got an exit question typed already. You're just going to hit that question. You're welcome. It's not a mixture one. It's one of the rectangle ones. So that'll be easier for you to get done real quick.
Really?
I
should have done it.
Somebody do that to me.
I got your 2 by 6. Appreciate that piece of paper. Appreciate it. I like them. That definitely just not saying my name on it.
Alright, just shut up in mind. So you've got a question there. Just shut up in mind.
The exit question. Pay attention. Did I pay attention? I got